Hello guys, welcome to this video. From this video, I will try to use some video to record how I learned Python and how I learned the pandas and numpy, right? So I will record a serial tutorial to record every day to show you some tips how to use this very um, important module in Python. We will cover of the numpy and pandas and also the matplotlib. Numpy is just a very useful Python model help you to just to handle some number value there. And pandas is just help you to handle the panel data, and the matplotlib is just to visualize your data to show you some graph. I will begin from a very basic one, and I will use this Jupyter to show you how to input output, because this is very easy to use, and also you can see the result right away. And in the background, I will also later when we go through some very advanced program, I will also show you this the Python. Okay, so first of all, you need to just import the numpy as np. If you didn't have numpy before, maybe the first thing for you just to use the pip install. For me, I use the Anaconda. I will suggest as a beginner, you also use the Anaconda because you already integrate a lot of the building function there. Also, you include different Python version, different a lot of the module like pandas, also numpy for the data analyze, also a lot of the machine learning. So it's very convenient for the beginner. You no need to search all the module by yourself, but instead you just install Anaconda and then that's it. And in the Anaconda, you can just define different virtual environment. Define like some program can only run under the 3.5, so you can create a virtual environment of 3.5. Later on, I can show you the detail there, but today just focus at this part. So first of all, numpy is very efficient because the code actually is writing in C. C is much efficient than Python, the natural Python, right? So also use numpy, you basically you can easily to handle all the array data. Array in the C, you know array, right? There's some number array has multiple dimension, 1 dimension, 2 dimension, and for sure, if you don't use numpy, you can use the for loop to handle that part. But compare the for loop and the numpy, numpy is much efficient. I can show you. For example, now we use numpy range, just like a Python range. You may know the Python range. This is natural, like a range one, like this 1000. Let's create a number from 0 to 99999, right? So numpy just the similar this range just in a numpy, the similar function. So I will compare you the two methods. What's the efficiency difference, right? One is using this is the natural Python, is your list, is building method, and this is numpy, is the numpy function. So we can do a compare. Okay, so basically what we try to do is this one, we try to we already create the my array. This is numpy disk the number array, right? So we use the this multiply 2. Later on, you will know that this one just is like a broadcast. Your broadcast within the whole number array. So just this, you can see this is very simple, as easy. Then this just means you will repeat this same operation 10 times. This one is underscore because you only use this variable within this loop, so you no need to give you a meaning name, so just use underscore to replace it. So you can see I run it, you can see only need about 334 milliseconds, then you can get back the result, right? So it's very efficient. And in the meantime, let's try the traditional Python nature way, which is this is the Python list, right? We just this is Python comprehension expression. Maybe you know that. So this one is also same, but basically it's a loop actually for every element inside this my list. So this element has so many, like about 100. About 1 million actually, right? So for 1 million data, we just multiply by 2, 1 by 1. So we can see how many times you run. You can see you need 1 second. So at least this is 3 times compared with the numpy and the Python nature. So numpy is much efficient. So that's why if you can see we only handle the 1 million, but when you in the real scenario, maybe this is maybe 1 billion, right? A lot of data. We call it big data analyze. So at that time, you will feel a huge difference between the two methods. So that's why we will try to use this numpy method if we can. Okay. And also, numpy has a lot of built-in function. I will show you let me see. Yeah. You may know that in the Python, there's some called random. The import random, then random int. You can create some random number. In the numpy is the same. Because, like I said, numpy is module focused on the number calculation. So that's why a lot of Python module like add, sub, multiply, division, you can always find the similar name in the numpy. But again, in numpy, you're writing in the C plus or C, so it will be much efficient. So here we just use the numpy random function, R&D, just create this array. Remember, in the numpy, the element we handle is always be array. This array means is 2 dimension, so mean 2 row, 3 columns. I can show you here. So you can see here 2 row, right, and 3 column. So that means it's a 2 dimension number array here. Also, each number you can see is a formula handled by the numpy, then can give you some random number, right? Then later you can just multiple, like I can just use this one to to multiply 10 for each element. So you can see this is an operation called broadcast. You just do one operation, then this operation will be broadcast within the whole number array layer. So each element will be get about 10 times. So again, this syntax is very simple, easy. Also, the running is very efficient actually. Not only this multiply, you can also do the other way, like the plus or minus or division. For example, this data bit data is equal to data multiplied to 2, right? So you can see here almost 2 times of this original one. So again, you can use a lot of other operation like a minus, like the multiply or like division. They always can use the same. Remember, we also this is called the 2 dimension array. So we can use some called the data shape because this is a special attitude of numpy array, so you can give you how many dimension of the array and what's the number detail in each dimension. For here, here's 2 row, 3 column, and for sure this not only support 2 dimension, you can support as many as you want, like a 100 dimension also okay. So you can see there will be output for the 100 tuple layer. How many dimension it has, you input how many elements tuple here. Okay. And also the other things, sometimes you may need to know what's the detail, what's the element type, right? First of all, this numpy, usually all elements within numpy should be the same type. For example, one type is string, that means the other should be string, right? Because it's easy for numpy to handle it. So this is the big difference between numpy and pandas. When we introduce the pandas, you will see that pandas actually is very powerful. It can handle different type. Actually, pandas is built based on numpy, right? You just encapsulation numpy inside it and do some more advanced operation layer. But anyway, this is D type is this attitude, so you can just show this each element within the numpy, the type. The float just means this float. 64 just means this number has 64 bits. So basically it's 8 bytes. Right? You can define float 32 or float 1 to 8. It's different, but they all mean a float. Also, you can just have an int as a string. Or if you don't want to specify the detail, you can just use some called object, right? Object 64, that means object that means everything, no matter it's int or string, but the bytes or bits still 64. Okay, and now I will just show you the latest one, how to create a new called ND array. You can see the type, right? You can see here type is the date. You can see this is the basic fundamental type in the numpy. We always call it ND array. Difference is some ND array is 1 dimension, 2 dimension, or 100 dimension, but they are all ND array. The different type, different shape, but the basic type is same, right? So here's one way how to create. I use called random mailer. The other is if I want to define a real I want to define element by myself, I can use this way. So this one you can see this data one should be traditional Python should be a list, right? You can see this is a list. List can also have some you can include analysis within it. So that's why we become 2 dimension. I can show you later on. So the numpy has a function called array that will convert other type to the numpy type, which is ND array. So now you can see this type type array 1. You can see it's become a numpy ND array type. So now you can see detail. You can see this become array, right? This array is type is from the numpy. So you can see this even the inside value is the same, right? Still be this one, but the type is a little different, a little change. And also you can see here, yeah, by default you already change it to the float. You can see here I usually, because remember I say element in the numpy should be the same. Because there's one from Python, that doesn't mean I need to be same. For this is int, this is float. But numpy detect this float, so they will convert others all in this float format. So here if you type in the array 1.d type, then it will give you the float 34, right? Because they need to make sure all element is the same to easy to future handle layer. So okay, and Also, this is just to show you the one dimension array, right? So I will show you how to do the 2 dimension, and later on you will know follow the same rule for the 3 dimension, 100 dimension, right? So this is a list of list, a list within the other list. So basically it's a 2 dimension. So I can use the same method to convert from the Python list to the numpy array. So you can see here's array 2 is the this is the detail. Then use the strip command. You can see it's a 2 dimension. Also the first dimension is row, 2 row and 4 column, and each one 2 dot d type. You can tell you the element type in the array. I believe it is another called dim, right? Let's try. No. Okay. Later I can do a Google search yet. I just try to let's say some value or attribute to show you how many dimension of the numpy array there. Okay, I think now should be that's it. And remember, this is just the beginning, and later on I can record more and step by step we can go through all the detail of the numpy and pandas. Thank you guys.